evaluate this double integral where R is the triangular region with vertices, there's 3, and we are asked to use these change of variables. X equals 2u plus v, y equals u plus 2v. So let's find the triangular region here. So 0, 0, that's the origin here. Then 2, 1 here and 1, 2. So we have this triangular region where we are integrating on. Okay, and our integrand is x minus 3y. It's not that difficult. And we are asked to use these changes of variables. So this integrand in terms of new variables u and v becomes x minus 3y. Just replace x by 2u plus v minus 3. Okay, and y is u plus 2v. So this simplifies to negative u minus 5v. Now we need to change this region, this triangular region, in terms of new variables u and v. This was in fact x, y. We just look at the transformation of these boundaries. Okay, here the first y equals 2x. Let's do this line. Okay, y equals 2x, and look at here, y equals 2x, and we are using y equals u plus 2v, which is given. That equals 2 times x is 2u plus v, and simplify, it comes out to be u equals 0. Similarly, second line, y equals half x, that's on the kind of bottom here, y equals half x, plug in x and y values, y, x, and simplify, we're gonna get v equals 0. And finally, this y equals negative x plus 3 here, and we want to convert this into uv as well. So y, just plug in y value given in the question, negative x, simplify, we get v equals 1 minus u. So basically the idea here is this region is not that easy to integrate on. So the whole idea here, when we do this change of variables, this transformation, we get slightly better, we get much better region. Okay, so let's graph the new region where we have y, u equals 0, v equals 0, and v equals 1 minus u. At the same times, when we do these change of variables, this integrand becomes easier as well. So in this case, it's about the same, but let's look at this region. So if we think u is x, v is y, so like u equals 0 means v axis, v equals 0 means u axis, and here is like y equals 1 minus u. So here I have graphed. So this is u axis, this is v axis. U axis means v equals 0, and v axis means u equals 0. Okay, these are the first two. V equals 0, u equals 0. Next, v equals 1 minus u. It's kind of y equals 1 minus x. So this line is v equals 1 minus u. So we have this region now. Okay, so if we go back, okay, it had name R. Okay, that was the region R. Now we can name this as new region yes. Okay, so the given integral, so then the double integral in R of the function x minus 3y, I believe dA, x minus 3y dA now becomes this new region yes. Then x minus 3y was converted into negative u minus 5v, minus u minus 5v, and this dA with this new region, we have to find the Jacobian of xy with respect to uv, and it will be absolute value. So we are converting xy into uv times this new area. new area of this region, and we can write du dv or du dv or dv du, so we don't know yet. So let me still write dA in the sense area of this new region. So let me find this dxy, Jacobian of xy with respect to uv. Okay, that will be just on side here. So we need to find the following determinant. I'm just finding this part here, by the way. Partial derivative of x with respect to u, partial derivative of x with respect to v, and same thing for y. yu, partial derivative of y with respect to u and v. Okay, and if we go up, x and y functions are, x is 2u plus v. Okay, 2u plus v, 2u means this is 2 plus v, so this will be 1. And how about y? Y is u plus 2v, u plus 2v, so this is 1 2, so this is 2 2 4 minus 1 3, and the absolute value of 3 is 3, so this is 3. Okay, so we just found this value 3. So this is same as, I'll write in terms of new variables u and b, negative u minus 5v, absolute value of 3, which is just 3, we can pull all the way outside. Now dA, this region, now we have two options. We can write du dv or dv du. Okay, it's up to you. And if we remember what we covered a long time ago, we can make this as a type 1. Okay, type 1, that means dv du, like dy dx, and u goes all the way outside, and v. For v, is looking at the bottom curve, v equals 0, up top curve, v equals 1 minus u, so 0 to 1 minus u. For u, this arrow could be taken anywhere here, 0 to 1. Okay, now this should be simple enough to integrate. Let's do it. So outside u equals 0 through 1, this 3 we can pull all the way outside if we like. Antiderivative of u with respect to v is, this is a constant, negative u v, minus 5v, antiderivative with respect to v, 5v square over 2. We're going to go from v equals 0 through 1 minus u, and du 1. Let's replace v by 1 minus u, so negative u 1 minus u, that's the upper limit, minus 5 halves, v is 1 minus u square, minus lower limit, but v equals 0 makes this term 0 and v square 0, so we have no contribution from the lower limit du. Let's simplify this. Uh, 3u from 0 through 1, distribute negative u plus u square minus 5 halves, 1 minus u square, and we need to distribute negative 5 halves. If we multiply 1 minus 2u plus u square, multiply by negative 5 halves, so negative 5 halves plus 5 halves times 2, 5u minus 5 halves u square du. We can combine, then integrate and plug in upper limit 1 0. Okay, it should not be that difficult now. So just combine like terms, we get here, integrate, then evaluate upper limit, lower limit, pretty much calculus 1, and the final answer is negative 3, final